Hi, in this video we will discuss the concept of left-sided limit. The left-hand limit is denoted by limit x approaching a minus f of x equals L. This means as x approaches a from the left, y approaches L. Now L can be a number, it can be a positive infinity, it can be a negative infinity. So what we see is that left-hand limit for a function f of x at a always exists. You will always have the left-hand limit. It could be a number, it could be a positive infinity, or it could be a negative infinity. Now, in this picture, we have a function. The function is represented by this graph. The domain of this function is 0 to 4. The range of this function is again 0 to 2. The domain is always measured along the x-axis from left to right. The range is always measured along the y-axis from bottom to the top. The endpoints are included, hence we use a closed interval. Now, let's begin to find the left-hand limit in this problem. Now, we want to find the left-hand limit of the function as x approaches 0 from the left. The minus sign on the superscript indicates the left-hand limit. You see that the domain of this function is from 0 to 4. So we cannot approach this function from the left. We cannot approach 0 from the left because there is no graph. We cannot find the left-hand limit of the function as x approaches 0 from the left. So this is not defined or does not exist. Now, what is the left-hand limit of the function as x approaches 1? As x approaches 1 from the left, the function approaches 0, hence the left-hand limit at 1 is 0. Now, what is the left-hand limit of the function as x approaches 2 from the left? As x approaches 2 from the left, the function approaches the open circle at 1. So the left-hand limit of the function as x approaches 2 is 1. Now let's go ahead and find the left-hand limit of the function as x approaches 3. So as x approaches 3 from the left, the function approaches a solid and the solid is at 2, hence the left-hand limit is 2. What is the left-hand limit of the function as x approaches 4? As x approaches 4 from the left, the function approaches 1, hence the left-hand limit is 1. By definition, the limit always represents open circle. The limit value is always the open circle. But we also consider the solids as well. Limit can be solid as well. So through this example, we learned what is the notation for the left-hand limit. The limit can be a number, it could be negative infinity, or it could be positive infinity. The left-hand limit for the function always exists at a point. In the given picture, the domain of the function is 0 to 4, the range of the function is 0 to 2. Hence, we had the left-hand limit at 1 is 0, the left-hand limit at 2 is 1, the left-hand limit at 3 is 2, and the left-hand limit at 4 is 1. We cannot find the left-hand limit at 0 because we cannot approach the function. We cannot approach 0 from the left because there is no function defined there. So the left-hand limit at 0 does not exist. And by definition, limit always represents the open circle. However, we can consider the solids. The solids can also be the limit values. If you have any questions, please write to me in the comments below.